Okay. First three problems. The first one's got multiple parts, 4 different parts. Ooh, don't flip it. So let's start with part A. We know that is the base of what? D to the third times D to the sixth. So who is first on my list? Charmaine? Oh.
Charmaine says she's having freezing going on, so we're trying to work through some glitchiness. And
Okay.
Kira's trying to see, but she is answering.
All right.
So you would subtract the 3 from the 6?
So what operation are we using?
Multiply. Sorry, not subtract.
So the bases D are getting multiplied. What do I do to the exponents?
Yeah, I was a little unclear, like when you add versus when you multiply.
Okay, so the base is getting multiplied. Thing on the
So
bottom.
maybe add them?
Yeah, so we're going to add the thing on top. And this is that sort of rule. I can write out D 3 times.
So 9 to the 9th power.
I can write them out 6 times. And if I look at how many total D's I got 3 plus 6, where I got D to the 9th. That's it. Oh, yeah. Right. Get out of here. Okay, next person, Fidel. This one's a little bit more. They're upping the level a little bit each go around, looks like maybe.
So it should be, I was just wondering, so for the bases, you do have to multiply them, right?
And we keep the base the same. The base
Oh,
stays
okay.
the
So it should be 4, then you would add the top, so it'd be 14x.
Yeah, we're adding 5x and 9x to get to the base of 4, and the exponent is 14x. So your base is staying the same.
Yeah.
The next one's a little bit different. Who's next? Jonathan?
This one will be you're gonna times the 2 and the 4 first, correct?
Yeah,
Mhm.
so that's a little bit different. So the way I would write this is 2 times, and that y by itself, I'd put a what on there?
You're gonna want to put a 3. Oh no, that's just a 1 for
Yeah,
it's
the
just
one by itself is an exponent of 1. That's what I was trying to get at.
Mhm.
And so if we're looking, and we're looking between each of these things, there's 4 different terms here, but they're all being connected through multiplication. So what you're telling me and what you used was like this thing called commutativity. So I can like look at these 2 things and put them together, right? I can arrange them so that I'm doing 2 times 4 is what, 8?
Yes,
think
it
is what you
should
said.
be 8y4.
Yeah, that's it. 8y
Y to the 4 exponent.
because we're doing that 1 plus 3 is where I'm getting this from, right?
I have a question.
Yeah.
If the 2 was a 4, would I do 4 times 4, or would I just leave 4 as? I'm just saying if it was a 4.
Oh, this is a 4?
Mm-hmm.
Yeah, you would have to do 4 times 4. So then this would be 16.
Gotcha.
Okay. And the last one here. Oh, we're going over these so quick. My best word of advice on these is to practice these things. You're not going to learn this thing through just like watching other people do it. Most of math is that way, but especially these. Like, you have to get used to these sort of things. These are going to come up again and again when we do other things. We're going to use exponent properties over and over again. So practice, practice, practice is my suggestion. All right, the last one here. Who did I not call? Vanessa?
Maybe W to 5.
Ooh, that's really close. What that first W there? Does that have anything on there?
Oh no,
So what do I put there?
that'd be 0 for that one.
To the 0 power is what? Like this one, right? That we're gonna do in a second. If we see it there, it's what?
Does that make it a 1?
Yeah, it should be to the first
To
power.
0?
I'm like writing at the top of my paper, so it's all squished. But this should have a first power, right? On number 1. And if that's the case, I bet you can get it right now. It should be W to the
6.
6. That's it. Yeah, it's like math is crazy. There's a lot of things there that like aren't there. You got to start seeing things that aren't there. I think it's called hallucinating, but we got to know, like, if we see a W, it's to the first power. If we want a coefficient on there out in front, right, we can do like a 1W to the first power. There's a lot of things that are we don't explicitly write that are kind of implied in the notation, and it's like it's just a matter of like learning the sort of language, right? I think to some degree. And in order to learn the language, you got to try to speak the language. The more you practice it, the easier these things get. And you just like, it's why it's sort of hard to teach sometimes, you know, because you take it for granted when you do so much. Yeah, it's not your first time seeing it. You do things without even realizing it sometimes, I think. Who's next? Jerry? Are you around? You logged in early.
Yeah. Okay.
Did you do 87?
No, I wasn't able to.
But you could do it right quick. What is my base there? What do I write as my base?
Why?
Oh, look at that. What is my exponent on this thing?
A and B
A what B?
times B.
What's the operation there?
Adding.
Yeah, it should be adding. We're adding the exponents if we're multiplying the bases. All right. We are on the last one. So who's next? Fernanda?
Would it just be 20 be 0?
20 to the 0. What does that mean?
There's no like exponent on top,
Mm-hmm.
or I'm not
If
sure.
I have 2 to the first, what does that mean?
It's just a 2.
It's just a 2. If I have a 2 squared, that's 4. So if I go this way, I'm multiplying by 2. So if I go this way, what is that going to be? If this is
0.
multiplying, 2 divided by 2, give me what?
1.
1. And this is true for like any number, right? So
Yeah.
20 to the 0 is going to be
1.
1. We're dividing 20 by 20 to get there, basically. B to the 0 is going to be
1 or
1. That's it.
okay.
Anything to the 0 is going to be 1. Except for 0. We're not talking about 0 to 0. That's something like you're going to start math fights over. You really will. People, there's different ways to interpret it actually, and I don't want to talk about it too much, but it's kind of the exception to the case. But any other number, b to the 0 is going to be 1. Questions of these? And we're talking about 0 exponents. I didn't do it on here, but I think we're heading next in that direction, right? Negative exponents.
Yes.
If I continue in that fashion, what's 2 to the minus 1? That's like what? I'm still dividing by 2. So what is that?
1/2.
1/2. That's exactly what it is. Okay.
I have a question about that.
Mhm.
What if the 2 was an A? I mean, a variable.
It's
Like,
the same thing, right? I know that a to the first is a. I know a to the 0 is 1. And I know a to the minus 1 is 1/a. We can generalize that sort of rule.
Okay.
Yep. As long as your a is not 0, but we're not talking about that. We're going to ignore that. We're going to act like 0 ain't an issue. All right. 89 is going to take you a minute. But I want to do 89. I want to do 89 is introducing a sort of new rule. It's kind of like we were multiplying, we added, and when we're dividing, it's the other thing that's not adding. And the next two, 97 and 101, are getting to negative exponents. I want to spend probably another 8 minutes or something like that over these things. Where are we at? 12:35? Yeah, we got time. Are there any questions over the stuff we just did? Those 3 problems. So if we have the same base, our exponents are getting added. If we have something to the 0, that thing is 1. I think those are the 2 new sort of rules happening here. All right. And so I want to look at 89, 97. Let me type it in the chat right quick. Let's say 89, 97, and what? 101. Okay. And off the groups if there's no questions. Let me resume recording. That might help. All right, so for these first 2, I feel like they're a little more straightforward than these ones. They're a little more complicated, maybe. So who is next? Brian, I think, was the next name on the list.
Yep. So me and Ashley discovered that I can't read because I don't know if that's a Q or a 9.
That's a Q.
Yep. So there we go. I got 1/Q to the 18th power.
Ooh, okay. And so you
I
did it one
don't
way.
know if that one was correct or not.
Yeah, so there's a few different ways you can do it. I think you probably just like saw that the number on bottom was bigger, and you probably said, I'm going to end up with more stuff on the bottom.
Yeah.
And you subtract the 2 numbers and you put that number up there. Yes, that's all good. That is a good way to do it. If I do it the old fashioned way, right? Like the way I was doing it, I'm going to do what? 18 minus 36. So you might notice you end up getting what? Q to the, what is it? Minus 18.
Yes.
So you might end up getting a negative exponent if you did it the other way. And then we have to ask ourselves, this is where the negative exponents come in. What does Q to the minus 18 really mean?
Q to the 18.
It means you got 1 over
Q to the 18.
0 over.
Q to the 18.
So I was correct in putting 1/Q to the 18th.
Yeah,
Yes.
that's it.
Okay.
And if maybe I could do an extra little step and say that this is Q to the minus 18 over 1 if I want to write it over something. So the negative, what does that do? The negative exponent, we're going to take whatever has a negative exponent, and basically, if there's no division bar, we're going to write a division bar in there and do over 1. And we basically move it from one side of that division bar to the other and make it positive, right? We basically flip it, make it positive. If you were looking at this thing and you did what Brian did at first, right? And you look at this q to the 36 and you say, well, the 36 is larger than the 18. I'm going to end up with more of those guys on the bottom. And you just subtract them and you end up with here without going through the negative exponent spot. This is where we're leading in the lesson, basically. Like, we're going to do these over and over again. We're going to get hopefully better at them to where we can just start seeing, hey, it's larger on the bottom. Probably end up with that many on the bottom.
So which way would be the correct way to do it? The way that I did it, the I guess, little simple way.
Either
quote
way's
unquote,
good.
Or, okay.
Either way's good for me.
I think teacher, they both are correct.
Yes. This is just
Because-
showing more middle steps, I feel like. But after a while, we're going to get around or hopefully get out of writing these middle steps.
Because writing it like q power 18, it's like just the positive. We don't need to have like negative there. Just 1 over q power 18.
If you do 1 over q to the 18th, yeah, that's correct.
So, I have a question. So the answer could be q to the 18th power.
Yeah, typically we don't want solutions with negative exponents. If there's a negative exponent, we're going to convert it to positive. We really don't like having those negative exponents in there.
Right. So, 'cause I'm just trying to double check. Like, would it be okay? So q to the 18th, or should I write it 1 over q to the 18th?
It should definitely have the 1 over.
Okay, gotcha. That's
Because
why
1 over q to the 18th is different than q to the 18th over 1 or q to the 18th, right?
Because we use the power of negative when just scientific numbers.
It's like the same thing if we take 2, that would be like 2 over 1. That's not the same thing as 1 over 2, right? Those are different things.
No.
Yep. Good questions. All right. Okay, and where are we at? And the last one on this one, 10 to the 2nd over 10 to the 3rd. Who is next? Carson?
For which one did you say?
Or this last one right here?
Okay, let me find it. I just got 10.
10 squared. What sort of 10? Just positive 10?
10 by itself. Is that not right?
If we do this, what am I subtracting?
2 from 3.
I'm going to do 2 minus 3. What is 2 minus 3 giving me?
-1. Oh, I see. And then you make it a fraction.
Yep. And so this is what,
Oh, okay.
1 over 10. If we look here, the 3 is greater than the 2. We're going to end up with 110 on the bottom. If you want to write 10 to the 1st, that's okay. But I'm probably going to eventually simplify it just as 1 over 10. That one's all right. Let's do this one too. So if I have a to the -2, and I want to write that over something. Carson, you still there?
Yes, I am.
All right. So I have a -2, a to the -2, and I want to write that over something. What can I write that over?
1 over a 2 or squared.
Yeah, I was trying to go for a middle step in there.
Oh, okay.
If I want to write this over something and I don't have anything to divide this by, right? I can always sort of divide this thing by 1. Any number divided by 1 is always itself. So if I need to put it over something, I can always put it over 1. If that's the case, and I kind of talked about it, we're flipping this, and this is going to be 1 over a to the 2, or 1 over a squared. So basically this thing gets flipped and this thing becomes positive. The exponent becomes positive. All right. Questions about these? Are we getting these? Okay.
Yes.
All right, so the next one is what? 10 to the minus third. Who's next? Diana?
I put it over 1.
Okay, 10 to the minus third, and we're putting it over 1. So
And
what
then
do
I
I
put
do?
it over the reciprocal.
Okay, so we're doing the reciprocal, so this looks like what? 1 over?
10 to the power 3.
That's exactly it. What about the next one? Help me out with the next one too. So now we're looking at 1 over c to the minus 5. A little bit different. Very similar concept though, right? Hopefully.
Excuse me, which number, teacher? It's 9. It's not 89.
97 is what I'm doing, right? 97 part C.
But we did 93 or no?
Yeah, we did 93 the first go round, I thought.
Ah, okay.
20 to the 0 is 1, b to the 0 is 1.
Yeah.
Anything
Yeah,
to the
I'm
0 is
just
1.
asking. 97. Yes.
All right, Diana, were you helping me with this one? Are you there? Where'd you go?
Me?
Yeah. This one's a little bit different, right?
Do I do the reciprocal again?
Yeah, you're flipping it. So what do we do with this? What's on top now?
C to the power of 5 over what?
Exactly, that's
But
it.
it could just be C over 5, right?
Yeah, c to the 5th. Is that a bird? Or a kid? Who knows?
It's my birds. They're like behind there. They're arguing.
Okay. All right, so this one, 1 over c to the minus 5th equals c to the 5th over 1. We're flipping that. This thing gets flipped to the top, it becomes positive. I don't have anything besides a 1 down here. And so this is, if we want to write it c to the 5th over 1, that's okay. But we should probably really be getting to what? C to the 5th? It's the same thing. Okay. Almost there. Who's it? Leslie is the last one here. 1 over 3 to the minus 2. How do I do that?
So would that be 9? Would that equal 9?
Oh yeah, that's a lot of work. So 1 over
So-
3 to the minus 2. So I'm
So you
writing
would-
that as
So it'd just be 3 over 2 over 1.
3 to the 2 over 1. That's it. Yeah. And like you were saying,
It would equal
3
9.
squared is 9. And so this is just telling me it's 9. Yeah, that's right.
I have a question.
Mhm.
When we have an answer like 3 to the second power, do you want us to leave it at 3 to the second power, or do you want us to go ahead and?
Usually if it's like low enough, like a single digit like 9, we're probably going to evaluate it. If you have like 2 to the 1,000 or something crazy like that, like they're probably going to leave it like that. But like for most of these, the numbers are small enough where it's shorter to write out just the 9 than 3 squared, right? It's like this is a little bit cleaner than this. So for the most part, I would say probably evaluate it if it's a number that you can evaluate.
Okay, gotcha.
You might see some crazy large numbers, like in the real world. That's usually how they do it. They're like 10 to the 100th or something, right? There's reasons why they do those sorts of things, because those are extremely large numbers. We don't want to write out this number that takes this amount of space when that 10 to the 10 takes up that much space. And I think we do that. We do some scientific notation in here, right? Scientific notation, we usually leave as exponents. All right, getting into the interesting stuff now. Look at this. 5/8 to the -2. Who was next? Sage?
I got 64 over 25.
How'd you do that?
Well, I had a question about that. Would you prefer something like that in decimal form or fraction form?
I would probably prefer fractions. What you said sounded like you're probably in the right ballpark.
Okay, I just wanted to make sure. So you want me to present the whole thing?
Yeah, what do I do next?
I rewrote it. So I wrote 8 over 5 to the exponent of 2.
8 over 5 to the exponent of 2. So what happened? You took that negative and you
Yes.
flipped this thing.
Yes.
Okay.
And then it's 8 to the power of 2 over 5 to the power of 2.
So if I wanted, I could write 8/5 times 8/5. So there's this other thing I can do, like this sort of distribution thing that happens here. And just to recheck, I'm multiplying those things. 1 times 2 to get 8 to the second.
Yes.
1 times 2 to get 5 to the second. So
Yeah.
this is this sort of distribution sort of property that we have when we have exponents to exponents, right? And then the last thing that you did was evaluate these terms. So you said, what, 64 over 25, I think is the first thing you told me?
Yeah.
Yep, that's it. So there's a lot of steps. There's a lot of different ways to do this too, right? If I wanted to, I could just do the distribution off the bat and do what, 5 to the -2 over 8 to the -2.
Yeah.
That's also another way I could do it. So this negative tells me that this gets flipped up. This negative tells me this gets flipped down. So then what I have on top is the same thing that I have like right up there, right? 8 squared over 5 squared.
Yes.
So there are a few different ways that you can handle these. You can handle the negative right off the bat and just flip everything and make your overall exponent positive. You could distribute things right away and then worry about making things positive. I would probably do this if I'm being honest, just to get rid of that negative. Okay. Trying to think. I think that comes up more with the next problem, I think. Okay. Alondra, I think you're the next person on my list. Minus b over a, and this is to the -2.
I just got A2 over B2.
All right, so let's walk through this. If I want to do this, what did you do first? What did you take care of first?
I just took care of the negative, so I just flipped it, and then I turned the 2 into a positive.
So instead of b over a, this is becoming what? A over
B.
b, and instead of negative, this becomes positive. That is really good. There's one little thing.
I just rewrote it and then put A2 and then over B2.
Yeah, there's one little thing that you probably really should. I think it's going to go away here because we're going to have a negative squared. But we should really be carrying that negative through
But if we flip it, doesn't it get rid of the negative?
It does not.
Okay.
What gets rid of the negative is actually the squared. So it's kind of like I have a -1 here, maybe. I don't know. It's kind of weird. If you wanted to write it with the A or whatever. But the next step is actually where it's going to get rid of it, because we're going to have like a -1 and we're going to square that. We're going to take the A and we're squaring that thing, and this is all over B and we're squaring that. So
It's like perpendicular things.
it factors out, but it factors out partly because like this thing is squared. If this was a cube, right, or any odd number, I think we would have to tack the negative along with it. So I think you should end up getting what, A squared over B squared?
Yeah, it's like perpendicular, teacher, right?
Oh,
It's
so I
what?
got the right answer. I just missed a step.
Yeah, you have to be careful, because if it's like anything else, like a cube or a fifth, we're going to have that -1 to the third is still just a -1 there. So overall, this would be a negative solution.
Okay.
It's like the slope for the perpendicular slope. We need just to change the sign and to
Flipped it,
flip the
and
whole thing.
yeah, it's a little bit different, but yeah, I see it.
Yeah.
Any questions about these? These are a little bit complicated. That negative really complicates things in that last one. But part of what they're trying to get at here is that we keep the negative going along. That negative exponent does not affect negatives in the bases, is what they're trying to get at with this problem. When we distribute that negative, if there's a negative on the base, we keep the negative on the base. Okay, so we got those problems. Now let's look at the next few. So 109's got a few problems there. 117. So this looks like maybe a little bit of mixed practice. Product property. So whether we have like bases or whether we have exponents to exponents, those are two different rules. So 109 is going to use, it looks like one rule kind of over and over again. And if it comes up with a negative exponent, simplify it. 117 looks like we're doing exponents to exponents. So we did a little bit of that before, but we did it with ones and other numbers. So it's a little bit more complicated maybe. So I want to go for those two. And then this one looks like it's also a little bit of mixed practice. So I want to go over these next three. And that last one, I feel like are probably the most difficult problems on this paper. But let's go over the next three, I think are the good ones to work on. So let me do a chat 109, 117. And give you a few minutes to work on those. Are there any questions over the stuff we did? If not, we're going to rooms. Let's recreate. Nope, open all rooms. And I want to pause, resume recording.
Yeah, I'm right here.
All right. So this one, b to the fourth, b to the -8. What'd you end up doing with this thing, or what'd you get?
I just put b to the 4 over b to the 8.
Oh.
And equaled b4.
b4 over b8. You converted that. I was not expecting you to do that, but that works. And what'd you get from this?
B4.
On top or where? Just b4 by itself?
Yeah, b4 by itself.
Where should that b4 go?
Oh, on the bottom. Yeah, it's 1 over before,
It
right?
should be on the bottom. Yeah. If the 8 is bigger, it should be 1 over b to the 4th. That is one way to do it. I was not expecting that way, so that's interesting. I like that. So I think you looked at this thing, you said this whole thing is over 1. I can move that b to the 8th on the bottom. That works. And like I said, there are multiple ways to do this. I can't talk anymore. The way I might have done it is doing what? The addition. If we have two like bases, we can add the exponents. So I get like b4 plus the minus 8 is going to end up giving me, I think, b to the minus 4, which will take me the next step. It should take me to the what? 1 over b to the 4th. Questions about this?
Yes, I have a question. When we do these problems, do we need to show the middle step, like, or can we just show our answers, or do you want to see like everything? If that makes sense.
I would like to see some work on this one.
Okay.
This one you should probably show some sort of middle step, at least the b minus 4 or something. There's not a lot of not a lot of letters in this one. When we get to the further ones, you'll definitely want to write out those middle steps just so you don't mess up. There's so many small little things you could potentially mess up on, and if I see where you messed up, I can give you more credit than where if I don't see where you messed up. If that makes sense. It usually ends up favoring the student if they write out their steps. I know you're like, I don't want to have to write out single one more thing than I have to, but write out that extra stuff. It really helps you on your grade. So you need to create a little slogan, when in doubt, write it out. I hope. Probably not. Okay, anyway. Jana, you're the next on the list. Jana here, or the next is Josh. Or the next is Michael Lima.
You said for 109, right?
We are on 109B, I think, right?
So I ended up getting W squared.
How'd you do it?
So I combined the W's, and so that's.
So you're noticing like these two things are the same?
Yes.
You're using like this sort of property that I can kind of rewrite this and like write them next to each other. I think there's like some maybe like commutativity, associativity sort of properties involved in here that we kind of use. But we're looking at those two things and we're looking at these two things kind of separately, right? I think is what you're doing. Right. And so from this, I got 4 plus a negative 2 is giving me a positive 2 over here.
Yes.
And this is giving me a what?
And that's going to be x to the power of -9.
Okay. And I'm still multiplying, right? Between these things?
Yes.
So if I want to combine these, how do I combine these? This is a W squared. What about this? How can I rewrite this?
Would it be 1 over x to the 9th?
It is exactly what it is. Yep.
Okay.
And if I'm multiplying these two things, it might help if I do that thing, right? Write this over 1 maybe. What goes on top?
So it'd be W squared over x to the 9th.
Yep.
So whenever we're simplifying all these problems, do you want there to be like no negatives in there? Is that what you mean by simplifying?
Yeah, so simplifying, when they say that, there shouldn't be any negative exponents in there. or
Okay.
zero exponents, but those are easy. You're probably just going to jump at them. But
What
yeah,
about
no.
what about the whole numbers? Like if, for instance, in the next problem or in 121, I have an answer that's negative 125 a cubed b cubed. Would the
Yeah,
negative 125 be all right?
So yeah, usually they want you to expand that out and write it out. That's right.
Okay.
We usually don't want like numbers to exponents. If we can evaluate it, we usually want it evaluated. So I think that's coming up in the next one. Definitely comes up in 121. So who was that? Michael Lima? Are you around?
Wait, which one are we on? 121?
109 part C.
Oh, I didn't do that one.
Okay. This one. So we got to be careful what operation we're doing. So I see as -6 and a -2. What am I doing with those two things? Or -6 and a +2.
Would you multiply?
Yeah, so I'm multiplying -6 and a +2. Those things get multiplied. I guess I'll go ahead and write it out. These things are getting multiplied, right? I'm writing out the like terms next to each other just so maybe it's a little bit easier to see. And we get a d to the 9th over there, and we get a d to the -5 over there. So I think this is what I was trying to get at, right? These are multiplied. And this is where we got to be careful, because if I take C, what am I doing now?
Adding the
I'm
exponent.
adding, yeah, so that is multiplying, this is adding. So I think I'm doing what? C to the first, D to the
D to the 4th.
D to the 4th, 9 minus 5. And if I were really to clean this up, like I would give you a check mark for that if I was grading this. But like if I really wanted to clean it up, I'm probably going to drop that one exponent. Questions about these? It's going to take practice, but one of the things you got to do when you practice is try to notice some sort of patterns in there. So there are different things that are happening to our bases than that are happening to our exponents. So really try to make those sort of distinctions between, hey, that's a base and that's an exponent. It's going to come up really well in like these next few. Y'all are going to start doing exponent operations when you should be doing base operations and vice versa. Best way to clean that up is, I know you're getting annoyed by me saying this, but practice, right? All right, so Gania, if we have y to the 3rd and we raise that to the x, what am I doing to this thing? There she is.
Excuse me, I was muted. Is it 125?
Yeah, 117 part A, y to the 3rd, and we raise that to the x.
Give me just 117. 117 part A, right?
Yeah, that's it.
Yeah, it's just y power 3, the whole thing power x. It's going to be y power 3x. We need just to multiplication.
It's multiplication between that 3 and that x is what I'm looking at. When I have exponents to exponents, and I said it in the notes, like your exponents are almost always a step behind, right? We start with addition. We define multiplication based on addition. Multiplication typically runs faster than addition, right? When we multiply things, it increases larger than addition. So it's like we're building up each time, like, and your exponents are always kind of like a step behind. So if we're doing exponents to exponents, they're a step behind. They're not getting exponentiated, they're getting multiplied.
It comes automatically.
So 3 times x is what I have over here.
Yes.
Or just a 3x, right? Is probably the way I'm going to write it, y to the 3x.
Yeah. You wanted me to do the next or?
If you want to do the next one, it's very similar, right? 5 to
Yeah,
the
it's the
x
same thing.
to the y. Yeah.
Just x, y.
I'm multiplying my x and my y.
And 5 power x, y.
X times y here, or just 5 to the xy. That's it.
It's the same thing for C too.
All right.
Yeah.
So C might be a little bit different.
It's like
But
the multiplication with the sign, with the negative.
It's pretty similar, except now I think we can actually multiply those things together. They're not giving us variables.
Yeah.
So I have what do I have here? Q.
Yes, you have q power 6, the whole thing power minus 8.
And so what I'm doing is I'm laying down that base.
It's q.
And my exponents get multiplied. 6 times a what? Minus 8.
Minus 8. Then it's doing minus 48 and put the whole thing down like 1 over q power 48.
And this is 1 over q to that power.
Yes.
To get rid of that negative exponent. Oh, I can't write correctly. My p's are turning into q's here, apparently. You got to mind your p's and your q's. Okay. Q and 48.
Yeah.
Questions about these? These are the sort of basic concepts, right? When I multiply the base, I add the exponents. When I divide the base, I subtract the exponents. When I go exponents to exponents, I multiply those exponents. Negative exponents get flipped. I think there's at least like 4 rules I just said there, right? Something like that.
Since you've been talking so much about practice, have you all ever used quizzes? Have you ever heard of those? Quizzes?
We are here in this class.
No, it's called quizzes.com.
Yeah, we used to use that a lot in high school, and it actually helped a lot with test reviews and everything.
Yes. So if you go to quizzes.com, I just put the link there. You can look up exponent practice. Here is an example of one quiz that you can do. So you can do the practice there. You can click and it's multiple choice and you go through and get some practice. If you like memes, you can see some memes. If you like power-ups, you get power-ups, or you can turn it all off if you don't like that and just get the practice. So I just wanted to make sure, since we talked about practice so much, that everyone had a resource to get that practice in.
Okay. Oh, we were cutting it close, aren't we? I didn't realize we're there already. Okay, so 121, I talked about this one. I want to do this one, and then I want to do this with a negative exponent. So this, if it confused you and you had no idea how to do this, you know what exponents mean? You could like write this thing out 3 times. Same thing. I'm just going to scribble scrabble over here. Same thing 3 times. That's so horrible. But this is -5 times -5 times -5. I think someone told me earlier, man, -125. I will say this. The most common thing people will tell me is -15. And this is that thing I was getting at. Like, you gotta like pay attention to what your exponents are and what your bases are. So if we have a base to that, this is -5 to the 3rd. So we're exponentiating this thing. Everything else here, like a, we had a to the 1st, we had b to the 1st. My a and my b are each getting a what?
they're not going to change. It's the only one which it's going to change the 5 minus 5 power 3. And it's going to minus 125, a power 3, b power 3.
Yeah, a to the power of 3, b to the
B-
power of 3, and that was coming from the 1 times 3 and the 1 times 3.
Yes.
So we're multiplying the exponents, but we are exponentiating the base. So there are different operations happening to this base than what happened to your exponents.
It's the same thing because it's the number. It's not the letter.
And we did this with the positive 3. I wanted to talk about what would happen if we threw a negative 3 in there. How's that going to affect it?
If it's the negative 3, it's going to be down.
Okay, so then
1 over
how does that
5.
affect the negative in the
No.
base, though? We didn't talk about that. So if we want, let me clear my annotations. So if I want to do this as what, minus 5
Over
8.
minus 3.
But
Yeah.
I want to do
No,
it
over
minus
minus
3.
5 by power minus 3.
So what y'all do? Take care of the negative in the exponent first? I think that was probably the class favorite for this type of problem. So if I want to do that, that gives me 1 over. Instead of writing this on top, I'm writing this on bottom, right? And this becomes positive. And I think I have the same thing, except this is 1 over. And now I'm doing 1 to the 3rd. I'm doing this thing to the positive 3rd. I think it's the same problem we had in the previous one. Except it's what? Basically 1 over minus 125. A to the 3rd, b to the 3rd. I think if people solve it this way, they usually don't come across the error. I think where that error comes in is when we start distributing the negative. So if you solved it that way, that's fine. But if you chose to distribute this negative, I think what people end up doing is they end up seeing a negative here and a negative here. But this is a minus 5 to the minus 3rd. It doesn't affect this negative in the base. This is still a 1 over minus 125, right?
But teacher, me, I know that I did just with like minus 125, a power 3, b power 3. It's correct too, right?
Minus 125, a to the power 3, b to the power 3. It should be 1 over that if we put a negative in the exponent.
Yes, you're right.
Because when we took over the negative, we flipped it. When people go about distributing this thing, I think is when they make that mistake. B to the minus 3rd. So if we're doing it like maybe this way instead. And this gives me 1 over a to the 3rd. I know it's getting really sloppy here. I'm trying to do this with a, but it should end up giving you this thing over here. So your negative and your exponents are not affecting the negatives in the base. We're not multiplying those negatives together and making things positive. That tends to be the mistake people make on this. All right. What about B? If I give you something like that on a test, I hope you rejoice.
That would be 1.
That's 1. Anything to the 0 power is just 1. All right. And we got 2 more. Who wants to walk me through this?
I don't know. I try.
Okay.
Okay, so since the exponent is negative, no, I don't know. See, now I just confused myself. Okay, yeah, okay.
Yeah, do it, go for it.
Right, because I was like, huh? But since the exponent is negative, you need to put why would that be -6? Would that be -6?
Yeah, we take that thing and we flip it, right?
Right. Oh yeah, I'm up and think you dropped the negative, but you don't. That's why, yeah. And then your exponent would be positive.
This thing becomes positive. So
Yeah.
this stays negative.
That's why I was keep getting confused. That I mean not, but yeah. 'Cause I was
And the
doing
next step, this is what, 1 squared? We can distribute that thing.
Mhm. And then that'd be 6. No,
And we're squaring this thing too.
yeah. And then you distribute that exponent.
So how do we, I'm sorry, what was that?
I said you distribute the exponent that 2.
Mhm.
And you it'll be -6 2 to the exponent of 2, right?
Yes, we got -6 to the exponent of 2.
And x to the exponent of 5.
X to the third to the second. So what is -6 to the squared?
-36.
If that minus is there and we're squaring the minus, what does that become?
A positive.
This is a positive 36. I know I'm being a really stickler about carrying your negative and the negative drops off, but it doesn't always drop off. That's why I'm like trying to hone in on it. X to the third, and then I square it. What do I get here? X to the
Right.
what number?
-6.
Positive 6. It's in the bottom, it's positive 6. It was in the top.
If it's in the bottom, yeah. Oh, if it's in the top, okay. Yeah.
And you leave your answer to that, like just like that.
That's it. 1/36, x to the 6. This is a positive exponent.
But minus y.
What's or where? What -1?
Yeah, why it's not -1? You said it's 1/36x power 6.
So there is a negative there, but that negative ends up getting squared out. So if you put the negative on the 1, when you squared that 1, or squared the -1, it should have became +1. If you put the minus on the 6, when we square that -6, it's going to become +36. So it depends where you track your negative, but when you do go through that square operation, it should square it.
Yes, yeah.
And you should end up getting positive. Now, if this was a cube, right? Like we had in 121A and I made it negative, it's going to stay negative, right? So you got to be careful. Sometimes your negatives will simplify out if you have an even number. But if you don't, they're going to stay there. Okay. And the last one. We get 3y to the -4 to the 2. What's the first thing I'm raising to the second power? What's the second thing I'm raising to the second power?
Multiplication.
So I see 2 different terms in here. I'm raising this thing to the second power. So I'm going to write this middle step.
So I actually did this a little bit different. I multiplied the 3 by -4. And so I got that as a -12 and then, wait, sorry, hold on, let me go back. So it becomes a -8 because you have one negative number. And that's numerator. And then you need to flip it to make it positive. So you get 1/4.
Are you saying y to the -8? That's what I'm hearing.
Sorry, no. So I had, my answer was 1 over negative 24y. Because I had, with the exponent of the 8.
So this 3 is like a separate term by itself. When we're looking across here, we're looking at things that get multiplied. And we're looking at each term that's multiplied. And so I have to look at this 3, oh, different color. I have to look at this 3 a little bit differently than I do this y. So the -4 squaring. So each term that's multiplied within there, I look at separately. If I want to fill out the exponent at 3, it's going to exponent 1. And so I'm raising exponents to exponents. So what is the operation I should do?
You'd multiply them, right?
Multiply exponents. So I'm multiplying exponents. So this is my exponent, this is an exponent, this is an exponent. So what ends up happening is I have this sort of distributive sort of property that should happen. And so I have something like 3 to the, now I'm doing what, 1 times 2?
One times 2, that's 2.
Yep. And I'm doing that y times what? Or y to the?
To the second. That's
What am I doing with these two things?
multiplying.
Multiplying to get to a?
-8.
That's -8. And then
And then it comes directly 9 times y power -8, and then you want to put 9 over 8 power 8.
yeah, so 3 squared is 9. Y to the -8 we talked about was the 1 over y to the 8.
Yeah.
So basically what this is kind of telling me is like that 9 is going on top, that y to the -8 is going on bottom.
Yes, and then it's going to be 9 over 8. Oh, no, sorry, 9 over y power 8.
Yep.
Yeah, it's automatically okay.
Okay. Any questions? We are like going over now.
Okay, I have a question.
Okay.
I know I'm saying my head overthinking it. But for D, the one that we just did, and how you got the 3y minus, 3y to the -4, and when you had to distribute that 2, and when you distribute that 2, how we had to multiply. Multiply. I know you already said it, but why we didn't add them? Like, why we didn't add the 1 plus 2? Like, cause I was like 3y to the -4, but you know how it's always 1 right there.
All right, so the rule with exponents is when we raise exponents to exponents, we're multiplying these two things. The other way to sort of see this is you have 3y to the -4th. This one's really easy because it's squared. I only have to write it out twice. But if I write it out twice, right, I'm going to end up having 3 2 different times. I'm going to end up having this y to the -4th and another y to the -4th. I'm going to end up having this 2 different times.
Okay, cause like I understand it, but like I was just, I think I'm
Yeah.
overthinking it.
These exponent rules, they definitely take some practice, and they take you like going through them a few times to like start getting them. Like they are something that people struggle with. So I know I've said it a million times, but like practice is really the thing to do here. You're working with the new sort of algorithm happening here, right? The best way to get used to it and adjusted to it is to use it, kind of like a language, right? Languages have their own semantics that you kind of have to learn. You have to learn how to conjugate words in those languages. Same sort of thing happening here. Like you have to learn this sort of language that's happening here. And it's a little weird. It's a little foreign the first time you see it, right? But the more you use it, the more you get familiar with it, and you just start speaking it without even really thinking about what you're even saying. Kind of like, kind of like how I teach class half the time. No, sorry.
So is this the end of class now?
Yeah. If y'all have questions, I can answer anything you want. But like, if y'all want to go and finish this off, and then there's that quizzes that will help you along too. That's it.